All right, let's talk about exercise 9.49, problem 5. I've got the DWF attached for you to look at the model, and I've got the PDF, which I've already opened, attached to the assignment. But essentially what we're going to do is take this transition from a square to a circle, and we're going to make it a sheet metal part. So I've got you some dimensions you can use for the thickness, bend radius, K-factor, and seam size in order to make it fit and look not crazy out of proportions. So we will basically be making 3 parts in order to achieve this. It'll be, the top part, which is just a round, the bottom part, which is just a square, and then the piece that transitions between them. It's pretty straightforward. The top and the bottom are made the same way. Essentially, you're just going to have a profile sketch and then offset a plane and then produce that sketch again and then just do a flange between them. You could do just an extrusion, but it feels like it takes a little more effort to draw this entire profile rather than just making a simple rectangle. So we're gonna do it that way, and then we'll add in a rip on this, and naturally it's the same for the top. The middle will be the same concept. The only difference is our bottom sketch is a rectangle and our top is a round. And then from there, we'll put in some work geometry if we need to in order to constrain the parts together a little better. But let's go ahead and jump in. So it's an imperial template that we need to convert to sheet metal if it's not already sheet metal. And, so from there we need to draw our sketch. Actually, I kind of forgot. We're going to set our sheet metal defaults in just a second. Okay, there we go. Had to get my Alt tab set up. And that is 2.25. This is 1.74. And we'll finish. So our sheet metal defaults, we have a couple things to change. The default is already 0.44 on K-factor, so we can just change this to still mild, thickness to 0.1046. The bend radius equals the thickness, so we don't need to change it. And then our miter rip seam gap, we're going to make 1/16, aka 0.0625. And we'll close this and do an offset. So for this part, we'll do the bottom, obviously. So we'll do 0.56. And this will be our top face. So from here, I can actually just project the 4 boundary lines. And that'll be our sketch. So nothing too crazy. We'll turn off the visibility of that plane. And just click the 2 profiles and choose die formed. From here, look at your blue boundary line. This was the absolute width of the part. So the way it's shown preview, it's going the wrong way. We need to flip that. So now you can see it hits the maximum boundaries and it looks nice. And then we can just do a rip. Okay. And I just drew it at a point where it constrained to the midpoint. I'll choose the point and the outer face. And it rips both ways. And, that's it for that part, actually. I'm going to delete all this. So I'm just going to put them in my downloads, but, save yours somewhere. Lovely. And then what I'll do is save copy as, and we'll name this one top. And so it doesn't actually rename this one. It just saves a copy elsewhere. So I'm going to go and open that. And the reason I did that is so we don't have to go and mess with the sheet metal defaults every time. Save us a little effort, and we can reuse this plane. And at this point, I can save top, and I can save another copy of this out to be middle. I'll open middle up. Okay, so for top, we obviously don't want the rectangle. So I'm just going to start a new sketch on our origin plane. And all this is a circle of 1.5. So I can start another sketch on that work plane we created earlier. And then I can project it to our sketch plane. Lofted flange. We'll probably have to flip the direction, but we'll choose die cast so we don't have this crazy hand folded shape. Yep, and we will flip. And then all we need is that little rip. I don't know if we'll be able to get such a convenient point this time. Let's see. Yeah, so it placed it on there, but it doesn't locate it completely. So we'll do a little horizontal. And then outside face and point. There we go. One thing I did forget to do on the other one, I'll do it in a second. Create the flat pattern. Just hit that button. That way we have it for later and detailing. And, you know, to let us know we're, you know, making it correctly too. If it doesn't unfold, it's probably not right. And save. All right, so this little guy will be 1.5 as well. But we need to change some values here. So I kind of forgot about this too. 0.56 for the bottom plane to plane distance. For the top, 0.44. Oops. Editing everything but the thing I need. And then the middle is technically you could do the math and it's 1 minus 3.25. But what I'll do just to show you some convenient stuff, we can do 3.25 minus 0.44 minus 0.56, and that gives us our value there. And we'll do a lofted flange, die-formed, and flip the other way. And then, so this part's a little tricky with getting the rip to work because that face up there is a little round and out of shape. We need to do it on the most orthogonal spot. So, you know, it's horizontal on the bottom and it's close to vertical here. Not really, but what we'll do is we'll choose this edge over here. And let's see if we can just snap it to the midpoint. We did. Cool. So essentially what we'll do is we'll rip from that point up. There we go. And, you know, the final test to make sure that it actually works as intended. Let's create a flat pattern. Nice. Okay. So I'll save this little guy. And there's a couple ways to place these in. If you had, you know, more patience, maybe you would click each one and copy it and paste it in. I'm just going to do, I need to open an assembly first, but I'm just going to do a place command, navigate to them, and pick all three. Okay. So, you know, this is one of the things that is tedious about constraining is you have to navigate to the origin planes a lot. So I'll show you kind of the general gist of how to constrain a part like this. It's not very fun, to be honest. It's a little mundane, but you know, it's the best way to ensure accuracy. So you go through and you choose plane to plane basically on everything. So there's our bottom plane. We'll do the corresponding plane for our origin. Then I believe it's this guy. Yep. So we've located it in all three directions in reference to the origin. So if I turn on degrees of freedom, you know, you can see these two guys move, but this one does not. So from here, it's a little wonky kind of constraining these together because you have all these weird faces. You can't really do like a traditional mate. So what I do, oh no, you know what I just thought about? The sketch right here. Yeah, man, y'all may have noticed this. I did not even think about it. It's not on center like that. So what I need to do for that middle part is turn the sketch on and project this edge here and draw a new circle. it's supposed to be 1 inch from this end, I believe. Let me double check. Yeah. So go back and fix that. All I did was, basically just delete the sketch and redraw it. You could actually unconstrain it. And if you did, it wouldn't do this if you just relocated it. But, it's not that big of a deal to fix it. So, oh, tragic. Okay, so we'll just delete my flange, keep all the sketches. Man, what a bummer. I'll keep that. Okay, lofted flange. All right. And naturally, it's going to pop up the error like, hey, your feature's wrong. Just approve. Don't worry about it. But same deal. We'll draw on that bottom face and snap it. And it still works the same as you see. The error is in regard to the flat pattern. So I'm going to delete that and recreate it. Make sure when you're reading those prompts that you look. Sometimes it's actually not a big deal. So what's funny is this new plane was created because I clicked the face and I got a weird spot. That's fine. It still leads to a rip. Ultimately, as long as it rips, it really doesn't matter too much. But okay, so let's go back, let our model update, and let's constrain it the right way. So now that I've finished constraining to the origin, I can hide that, and I'm going to basically just do the same thing, matching up the origins of, well, work planes and origins of these two parts. So, well, conveniently, I should actually just be able to do that. Huh. Seems a little big. Oh, okay. No, it doesn't. Cool. So you could try to do like a mate from here to here, but you're not going to know exactly like where the correct spot is, as you can see. So the easiest thing to do is simply use those planes we used to draw as your constraining point. So I'll do the work plane to the origin plane. And then we need to locate it in this direction. So we'll do these two. And then, I wish you could just do like an insert here, but it would kind of be wonky. You could make it fit, but, we'll just keep up the same premise. And we want all the seams to be on the same side. So let's expand this out. And essentially what we're going to do is just work through this. So I don't know if you noticed, I kind of had to look into it. Sometimes you have to, but you want that seam to be on the right side as you do this. Oh, wrong plane. So do that one to the origin. Let's see what we're missing. Okay. And again, I'm gonna have to flip the solution. And it came out weird. What did I do here? Oh, okay. Makes sense, right? So my origin plane cuts through the middle of the rectangle. So up here, you don't have a round spot. So what we need to do is just make an axis that runs through here. So I should just be able to grab something through here. Let's see. Yeah, what's tough actually? Guess we could do like, it would actually be easier to do the a sketch of it probably. I want to try to grab something for it. Maybe like a origin plane. No. The easiest way is probably just to turn the sketch visibility on. And basically I'm going to choose my sketch middle point of that circle and then a plane that goes through it. Oh no, and it made it the wrong way. Okay. Let's try that again. There we go. And I chose the bottom plane and it creates it through it and gives us a little constraining point. So I'll turn that sketch visibility back off. And let's see. So I need to edit this sketch, the one that is locating in that direction. And what I'll do is choose my solution for that part. And if it's on flush, it doesn't allow you to choose axes FY, so I had to flip it to mate. And then when I did that, it updated. So yeah, that's actually, you know, the premise of it. We've got 3 parts that all make up this shape here. You know, it's more aesthetically pleasing, but same concept. You essentially have created a transition, you know, from one shape to the other. So if anyone's having any questions on how to model this, just let me know.